recording. Share the screen. Okay, so I hope you enjoyed your one-day weekend, as I sometimes call it. So we are over here. Okay, so I'll be starting 5.3 today. I'll probably finish early, in which case you can ask questions or not. Okay, tomorrow's quiz will be material from 5.2. I will have you take an exponential function and you do stuff to it. So move it left, right, up, down, reflect across the x-axis, reflect across the y-axis, multiply it by 2, stuff like that. Okay, so, and you've seen that theme before, so it shouldn't be anything new. All right, so I think I have plenty of time today and tomorrow, and even if I don't finish tomorrow for 5.3, I still have Monday because I have extra days, I think. 5.4 is all word problems. I'm not trying to scare you too much, but there's a certain exponential growth function that you have to get used to, and it's very calculator dependent also, so it'll take a while to develop those problems. Okay. All right, so on to 5.3. I gave you some introduction last time, and I'll do my own stuff also. So before doing any of the problems, I did some introduction last time from the text, and here's my version of it also. Okay, let's take the function y equals e to the x. Okay, e is this funny number. It's about 2.7. And again, on your calculator, you should have a button that has e to the x. It's normally paired with ln, so e to the x, ln x. The value of e is about 2.7. Again, if you have a button that does e, then just hit the e button. If you don't, you can trick the calculator by doing e to the first power. So just for fun, let me show you e to the first power. Sorry, here we are. E to the first power, 2.71828. It's an irrational number, like pi. It has infinitely many digits. Just like, you know, I do have a pi button. And there's pi, 3.14159265359, blah, 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 blah. Okay, so you can see e is also this super long number. It goes on forever, never terminates, never repeats. Okay, so approximately 2.7. All right, so this is e to the x. If you reflect across the line y equals x, you have the inverse function, y equals natural log of x, ln, which again stands for natural log, looks something like this. Okay, here's the line y equals x. Okay, both e to the x and ln x are one-to-one functions. That means they pass both the vertical and horizontal line test. So what's all these horizontal and vertical lines? Okay, it shows you that we have a one-to-one function. And you might recall one-to-one functions have inverses. So e to the x has an inverse. Okay. If you switch around the x and y, it's x equals e to the y, or y equals natural log of x. So these two actually say the same thing. Okay, so y equals ln x means x is equal to e to the y. Okay, so these mean the same thing. Okay, if you look at the exponential function, the domain is all real numbers. You can have any real number, but the range goes from 0 to infinity. Okay. So if you take the inverse, you might recall for the inverse function, the domain and range just swap places. So the domain of one becomes the range of the other. So for the inverse function, x equals e to the y, which means y equals ln x. The domain is 0 to infinity. So if you look at the graph, the red graph, there's nothing over here, and it doesn't touch the y-axis either. So the domain is 0 to infinity, but the range is all real numbers. Okay? So among other things, that means you cannot take the natural log of 0, nor the natural log of any negative number. Okay? And that's verified on your calculator. And if I try to hit ln of 0, say ln of 0, I get error. Right, ln of 0. And on my calculator, if you do ln of -1, I think it gives you a complex number. Yeah, it says 0, 3.14, which looks like pi. Okay, that's actually 0 plus pi I, but we're not going to worry about that. Right now, we're only doing real math, no complex numbers, no imaginary stuff. So for real numbers, ln of a negative is not possible. Okay. All right, so little bit more on logs. Okay, I'm not doing any homework problems yet. I'm just introducing the logs. I'll get the homework problems soon enough. Okay, so if you have y equals a to the x, that's 1 to 1. Exponential functions are 1 to 1. You can get the inverse, remember, if you switch around x and y. So if I switch around x and y, it looks like x equals a to the y, or we'll make up the log function, y equals log base a of x. So again, these two mean the same thing. So x equals a to the y equals log base a of x. Now, the way I remember how to unscramble it, this is my wording, it's not official words when I say unscramble it, meaning get rid of the log. You start with the base, which is a, the thing that's next to the g, sunken down, that's a. You go across the equal sign for the exponent, so it's a raised to the y power, then you come back in for the result. Okay, so you go like this, a raised to the y is equal to x, a to the y equals x. Now, for natural log, ln x means log base e of x. So ln, which stands for natural log or log natural, we almost never write that log base e, we just have a shortcut, ln. But if I play the same game, how do you write this without the log? Y equals log base e of x. You start with the base, which is e, exponent is y, come back in for x. So e to the y equals x, or x equals e to the y, which was the same thing as I was trying to show you back over here, that these mean the same thing. Y equals ln x means x equals e to the y. And if you want to put that in your cheat sheet, you may. Okay, so in general, okay, if you have a log equation like this, say, I don't like logs. Okay, well, I don't like them that much more either. How do I get rid of the logs, right? So to get rid of the logs, start with the base. So for the logarithm equation like this, there's generally 3 parts. 1, 2, 3. The base, the thing all by itself is the exponent, and then the result. So start with the base. You cross the equal sign for the exponent, so b to the y. Come back in for the result of x. So b to the y equals x. Okay, the equal sign might be switched too. So the log base b of x might be on this side. You still start with the base, cross the equal sign for the exponent, and come back in for the result. Okay, so here's some examples. Log base 2 of 8 equals 3. How do you write it without the log? So start with the base. The base is easy. It's always the thing that's sunken down next to the g. So 2. Exponent is on the other side of the equal sign. In this case, I have to go that way. Now over here, I have to go that way. So be careful. The log might be on the left side or the right side, but the rule is you always cross the equal sign for the exponent. So if you look over here, right, to cross the equal sign, you'd have to go that way, b to the y equals x. But when it's written like this, when you cross the equal sign, you got to go to the right. You just look at where the equal sign is. The other side of the equal sign is the exponent, so 2 to the 3rd power, and then come back in for the result of 8. And we know that 2 to the 3rd is indeed 8. Okay, let's try log base 10 of 10,000 equals 4. Okay, and by the way, if you don't see any base there, it's understood to be base 10. So if you just see log of 10,000, it means log base 10 of 10,000. Okay? So the understanding is every log has a base, and if you don't see a base, it's understood to be base 10. And your calculator should obey that rule too. Like here on my calculator, I'm pretty sure on your calculator, it just says log, right? You say, I wonder what the base is. It's 10. And you can't really forget, because if you forget, just peek up here, 10, right? And likewise, I mentioned before, see ln, I forgot, what's the base? Just peek up here, it's e. Although what's e again? It's about 2.7. But after a while, when you see e enough, you know it's about 2.7, just like pi, right? Most of you, when you say pi, okay, 3.14, I've heard of that before. So likewise, after a while, when you do e so much, e is about 2.7. That's probably all you need to know, 2.7-ish. Okay, so I see log. Okay, they didn't bother to put the little 10 there because that's considered the convention. If you don't put a 10 or 7 or anything else, it means 10. And if you ever forget, just peek up there. Okay, so log base 10 of 10,000 equals 4, they say. How do you write it without the log? So the base is 10. Go across the equal sign for the 4. So 10 to the 4th is equal to 10,000. And we know that's true. 10 to the 4th equals 10,000. Okay, and by the way, we have a button that does log base 10, log of 10,000. So just for fun, let me do that. And you can try it on your calculator now or not. If you have your calculator handy, go ahead and try it. But if not, just follow the notes later. But I'm claiming log 10,000, like so, ought to be 4. There it is, 4. Okay. Now, if you have a scientific calculator, which isn't a graphing calculator, you might have to go backwards. So I'm reaching for that type of calculator now. So if you have a calculator that's just something like this, where there is no graphing calculator option, it's just scientific, then you might have to go backwards. And what I mean by backwards is this. You folks might have to hit 10,000 first. 1, 0, 0, 0, 0, 10,000, and then hit log. And there's the 4. Okay, so just experiment with your calculator. It's either going to be what I just did, 10,000 log, or this one where it's literally log 10,000. I got both types of calculators just to show you both. So most calculators that I've seen, I'm guessing your calculator fits one of the 2 categories. I haven't seen anything else. Okay, now, I'm not a calculator expert, but that's mostly what I've seen. You either hit log 10,000 or 10,000 log. Okay, it's one or the other. Okay, now you say, why don't I do that for log base 2 or log base 5? Most calculators can't do that, although I now see some calculators can do that. And by the way, if your calculator does it, great. I'm not letting you use that feature on exams. You have to be able to show me that you know how to do all this unscrambling stuff. Okay, so you can't rely solely on your ability to do log base 2, log base 7. Some of you can do that. My calculator can't, but I know there's calculators out there that do that now. You have to do it the way we do it in class. Okay, log base 5, a square root of 5 equals a half. Okay, so I can't do log base 5 on this calculator. I can only do base 10 and base E. If you have it, fine, but you can't use it solely. Okay, unscramble it. 5 to the 1/2 power equals square root of 5. And of course, we know that's a definition of 5 to the 1/2. And finally, here's an example where all they give me is letters. Log base A of B equals C. So write it without log. So start with the base, A. And then is the exponent B or C? Exponent is C. You go across the equal sign, A to the C, come back in for the B. Okay, then over here, what if you start off with an exponential equation? How do you write it as a log? So we're going the other way now. So suppose you start with 3 to the 4th equals 81. How do you write it as a log? Well, first, I guess I better write the word log, L-O-G. Which one of these 3 units, the 3, the 4, or the 81, which one is the base? The base is 3. So log base 3. And then all you have left are the 4 and the 81. So is it 4 here and 81 here, or vice versa? Okay. Remember, the way it works is the exponent is all by itself across the equal sign. So equals 4 here, and 81 comes back. And you can always unscramble it to double check. 3 to the 4th equals 81. It's not 3 to the 81st power. 3 to the 81st power is real big, right? 3 times 3 times 3 times 3 times 81 times. That certainly can't be it. Okay. 10 to the negative 2 equals 0.01. Write it as a log. So if I'm going to write it as a log, I better write log, L-O-G. Start with the base. The base is 10, which actually means you don't have to write it. So I put the 10, but it's optional. You can leave it off. And then exponent is all by itself. So negative 2 goes there, 0.1 here. Okay, so log base 10 of 0.01 equals negative 2. Or, again, just drop the 10. Log of 0.01 equals negative 2. This is understood to be base 10. Okay, and I can do base 10. So log 0.01, just double check. So I'll hit log 0.01, negative 2. By the way, some of your calculators, once you hit log or ln, it automatically pops up with a left parenthesis. Okay? So if your calculator does that, just close it with the right parenthesis. So 0.01, then just close it with the right parenthesis. And same thing. Okay? Again, if you have a backwards calculator, a regular scientific calculator, you folks would have to go backwards. So for you folks, I'm going to hit 0.01 and then hit log. And there's a -2. So you might have to go backwards. Okay. All right. X to the y equals z. How do you write that as a log? So this arrow means is equivalent to. Okay, that means the left side and the right side mean the same thing. This means that. This means that. Okay. So write it as a log. So write the word log. Start with a base, which is the base, x. Now all you have is y and z. So is it y here and z here, or z here and y there? Okay. Exponent all by itself. So y and then z. Okay, then a little bit more theory. Okay, just like e to the x and ln x are inverse functions, that can be true for any base. So a to the x and log base a of x are inverse functions, as long as you have the same base. So if this is a 2, this is a 2. If this is a 7, this is 7. They are inverse functions of each other. Okay, and in general, if a is bigger than 1, it's the same general picture as this. So a to the x like that, log base a of x like that, y equals x. Okay, so the reflection of the exponential is the log and vice versa. Okay, so notice all log functions generally look like this. There's nothing over here. So again, we can only take logs of positive quantities. So log base 10 of 0 does not exist. My abbreviation for does not exist would be DNE. And that, some books use that also. I already did this. Natural log of -1 does not exist. But log to any base. So log base 10 of 0. So here, let me try log of 0. And I'm expecting an error message. Sorry, error domain. Okay, so log of 0. Or again, for those of you with this calculator, you have to go backwards, 0 log. So 0 log E, error, I guess. So clear it out to get back to where we were. Okay. All right, and finally, I'll be able to do some problems now. Okay. So 5.3, 1 to 65 odd. So again, I'll show it to you on the video for those of you who don't have the book. A little bit more, a little bit more. I guess we have to go to 65, so I have to turn the page from one problem into matching. So 1, 2, 3, and 4 up there. Okay. All right, so number 1. Log base 4 cubed. Okay. My suggestion for all of these is to call it x, just to get the ball moving. Say equals x, equals x, equals x, or y, or whatever. Okay. So the problem says log base 4 cubed, call it x, and then unscramble it. So 4 to the x equals 4 cubed. I would just look at it and say x has to be 3, right? So if two bases are the same, right, the exponents have to match. I mean, think of it logically. 4 raised to something, 4 raised to something. Well, the bases are the same, so these two exponents better be the same. I mean, if this one's a 3 and this one's a 4, it's not going to be true, right? If this side is a 3, this side better be a 3, so x equals 3. Okay, 5. All it says is log base 4 of 2. We're going to put the x. Again, for all of these, across the board, 1 through 15, if you're not sure what to do, call it x. And you can go from there. Unscramble it, 4 to the x equals 2. Okay, now what you want to do is get both sides to have the same base. This is already 2. Can I write 4 as base 2? Well, yeah, 2 squared. And this is 2 to the 1. So Okay, if I have a power and then another power, I get to multiply the powers. 2 to the 2x equals 2 to the 1. So that's what I want. I got 2 to something equals 2 to something. So the two somethings have to be equal. So that's easy. 2x equals 1, x equals a half. Okay. 7, log base 10 of 0.001. That's the way the problem started off. Call it x, unscramble it. 10 to the x equals 0.001. Okay, I want these to be the same base. 0.001 is 1,000th. Remember, this is tenths, hundredths, thousandths, so it's 1,000th, which I can write as 1,000 to the negative 1. And how do I write this as base 10? Well, 1,000 is 10 cubed. 10 cubed to the negative 1. Now I can multiply these two. So 10 to the x equals 10 to the negative third. So x is equal to negative 3. Okay, then a little review of a function and its inverse. You might recall anytime you compose a function with its inverse, they cancel each other out, so you just have x. So f of f inverse of x is x. Likewise, f inverse of f of x is equal to x. Okay, so among other things, that means anytime you have something like this, log base a of a to the x is equal to x. Okay, because you're doing exponential followed by a log. And likewise, a to the log base a of x, you do a log followed by an exponential, you have x. So that means way back to this one, you could have immediately said the answer was 3. I would have accepted that. Okay, because it's a function with its inverse. But if not, you can still do it this way. Okay, now, that means anytime you have an ln and an e back to back, they cancel out. So ln of e to the x is automatically x. Likewise, e to the ln of x is x. Okay. And same thing for logs. Okay. This is base 10, understood. Log base 10 of 10 to the x is x. And likewise, 10 raised to the log x is x. Okay. What that means is that some of these problems are very quick. Look at 11. E to the ln 5. The answer is automatically 5. E and the ln cancel out. Likewise, look at 13. ln e to the 1/3. The answer right away is 1/3. There's really nothing to do, right? E and ln cancel out 5. ln e cancel out 1/3. That's pretty much how easy that kind of problem is. But let me show you a little bit harder would be 15. Okay, so let me show you 15. Well, I'll talk a little bit. Okay, 15. There's an E and there's an ln. Now, if that 2 weren't there, if 2 disappeared, I just say E, ln, cancel out the other pi. There's a 2 in the way. Right, so how do I get that 2 out of there, so to speak? Okay, let me show you what you do in that case. So E to the 2 ln pi. It's problem 15. Okay, what you want to do here is one of the properties of logs is that you can bring that 2 up here. Okay, when you have a log, the 2 is allowed to go up as an exponent. Okay. So I showed you that log a while back. The 2 can come up or it can come down. Okay, well, why don't I go ahead and show it to you in the text? Yeah, this one, page 298. I showed you, I think, Tuesday. Log base a of x1 to the r equals r log base a of x1. So that exponent r can come in front, but it can also climb back up. Okay, these equations were both directions. Right? Quick review: log of x1, x2 log of the first plus log of the second, log x1 over x2, log of the numerator minus the log of the denominator. And log of x to the r can come down in front, but it means you can also climb back up. So that's what I'm doing here. The 2 climbs back up. And now the e and the ln can cancel out. So it's just a pi squared as my answer. Okay. Right, so that's how that one works. Okay. And now, next I wanted to show you. Let's see. Okay, this is just a rehash of stuff before. The exponential function and log function to the same base are inverses of each other. So if f of x equals a to the x, f inverse of x is log base a of x, as long as you have the same base. So let's say 2 to the x and log base 2 of x, inverse function. 45 to the x, log base 45 of x, inverse function. Okay, so y equals 2 to the x has an inverse x equals 2 to the y, switch on x and y, which means the same thing as y equals log base 2 of x. That's the inverse function. Okay, and I summarized this here. You don't really have to write this down. I've said it, or you can look at the video later, but I'm not waiting for you to write it down, put it that way. Okay. So we're using the property that f of f inverse or f inverse of f is equal to x whenever it's defined. So a raised to the log base a of x is x. It can be written like that, or it can be written like this. Log base a of a to the x is also x. Okay, so that means 2 raised to the log base 2 of x is automatically x. Log base 3 of 3 to the 7th, 7. Same base. 10 raised to the log of 4, 4. And that's understood to be base 10. Or log of 10 to the pi, pi. This means base 10. E and ln back to back cancel out. E to the ln 2, 2. ln e to the 1.3, 1.3. Okay. Again, ln means log base e of e to the 1.3, 1.3. Okay, so I showed this picture before, I think. Okay, so here's e to the x, 0, 1. Inverse function is ln x. So this is 0, 1, this is 1, 0, which means natural log of 1 is 0. Domain of the red function, all reals, ranges from 0 to infinity. Inverse function, switch it around. Domain, 0 to infinity, range, all real numbers. Okay, and rehash again the properties of logs. I've said it before, I'm going to dig a little bit deeper. Log base b of xy is log base b of x plus log base b of y. Language, the log of a product is the sum of the logs. Okay, so here you multiply, here you add, that's what it says. Okay, so example, log of 28, log of 4 times 7, log 4 plus log 7. Log base b of x divided by y, log base b of x minus log base b of y. Language, the log of a quotient, division problem, log of a quotient is the difference of the logs, I subtract. So ln of 15 divided by 5, or 3, is equal to ln 15 minus ln 5. Okay, and then just developing the last law, log base b of x squared. Well, that's the same as log base b of x times x, which means I can go use this rule. It's a log base b of x plus a log base b of x. I got 2 of them. Log base b of x cubed. Log base b of x times x times x. So log base b of the first plus log base b of the second plus log base b of the third, but they're all the same. So 3 log base b of x. So quick summary over here. Log base b of x squared is 2 log base b of x log base b of x cubed is 3 log base b of x. So that seems to justify, oh, it looks like I can just bring the exponent down in front, which means I can climb back up again, which is what I just did. Okay, so this is sometimes called the power rule. Log base b of x to the n is equal to n. N can come down in front, n log base b of x. But again, it's both directions. You can start off with a coefficient and have it climb back up, like I did for that previous problem. Okay. So, for example, log of 2 to the 10th, that happens to be 1024, is equal to 10 times the log of 2. Okay, and just for fun, let me see if I can show you that in the calculator. So log of 1024, so log 1024, oops, sorry, 3.010 whatever. And then 10 times the log of 2, 10 log 2, 10 times the log of 2. And exactly the same, every digit is the same. This is what I'm getting there. Okay, so yeah, getting back to problem 15. As I said, so e to the 2 ln pi that I just did, make that, you want the e and the ln next to each other, make the 2 climb back up. So it's e to the ln pi squared, cancel pi squared. Okay, I'll just do a couple more and then we'll stop. I think I'm good for today. 17, ln x times x plus 1. Use the properties of logarithms to simplify the expression so the result does not contain logarithms of products, quotients, or powers. Ln x times x plus 1. Okay, so that's ln of a product. So it's the sum of them, ln x plus ln x plus 1. Okay. In 19, a couple of things going on here. Log base 3 of x to the 4th over x plus 1. Okay, there's a division here. So can you guess what happens if I have a division? I will subtract. Okay, and then beyond that, there's a power. So what happens to the power? It's going to come down in front. Okay, so log, I'm using this, the log of a quotient is the difference of the logs. Okay, so log base 3 of x to the 4th over x plus 1 is a log base 3 of x plus 4 minus a log base 3 of x plus 1. Okay, and then with that 4, I'm now using the power rule. Right? Log base b of x to the n can come down in front, n log base b of x. Okay, so where was that? That 4 comes in front, so 4 log base 3 of x minus log base 3 of x plus 1. And there we go. Okay. So some of these others are, you can see they get kind of complicated, but you're just basically doing the same rules. Okay, I mean, these look so bad, right? Really horrendous. But if you make use of the properties of logs, it isn't going to be that bad after all, if you do it the right way, I guess is the way I want to say it. Okay. All right, and let's see. Do I have time for one more or two more? Yeah, I think I can do that. Okay, how about I'll show you 23. That looks pretty bad. So log of that times that divided by that times that. Okay, I got exponent, exponent. I can change the square root to x plus 1 to the 1/2 power, right? So do that one. Log basically of this big mess. Okay. This is a multiplication, and both of these are in a denominator. Subtract. So log base 3, 3x plus 2 to the 3/2, plus log base 3, x minus 1 cubed. And since both of these are in the bottom, they're minuses. Minus log base 3 of x, minus log base 3 of square root of x plus 1, x plus 1 to the 1/2 power. And then this comes in front, this comes in front, this comes in front, and this doesn't have anything to do. So final answer, 3/2 log base 3 of 3x plus 2. 3 times log base 3 of x minus 1. Leave that one alone. Minus 1/2 log base 3 of x plus 1. And we are done. And that's it for that. Okay, so I'm done today, folks. So tomorrow I'll do more of this. I'll check the chat to see if you have any questions. So I'll keep going. The quiz will be on section 2 stuff. I'll give you an exponential function, and you're going to do stuff to it, like make it bigger, make it smaller, reflect, move it left, right, up or down, and so on. And we have time for that. So we have plenty of time for the next exam a week from tomorrow. Just 3 sections. We're only covering this, and I've already started some of this already. Anyway, okay. All right, so that's it. Let me stop the share, check the chat. Nothing in the chat, looks like. Okay, so anybody have any questions? If not, we're going to call it a day. Okay. Any questions, please? A lot of you are already saying thank you. I guess that's your way of saying, I don't want to do any more, let's quit. Okay, all right, that's it, folks. So have a good day, and we'll see everybody tomorrow. Okay, thanks. Bye, everyone.